Hello everyone, today we are going to discuss about durable execution and one more thing, it is very powerful concept, that is task, mean how to create the task in the LangGraph. It is saying durable execution is a technique in which a process or workflow saves its progress at key points, allowing it to pause and later resumes exactly where it left off. This is particularly useful in scenarios that required human in the loop. So, for example, wherever we need human in the loop, so at that time we'll use durable execution. We already discussed about human in the loop and time travel a little bit, but we will see this concept in upcoming videos in more detail, in more depth. And it is saying where users can inspect, validate or modify the process before continuing, and in long-running tasks that might encounter interruption or error. Okay, after that it is saying to leverage durable execution in LangGraph, you need to enable persistence in your workflow by specifying checkpointer that will save the workflow progress. And you also need to specify thread identifier. We already discussed about checkpointer, thread ID and in-memory saver. I know that I can understand you maybe forget about these concepts, but the thing here is whenever we'll discuss these concepts in more detail, or whenever we'll use these concepts in some application and we will build some applications by using these concepts, then the concept will be clear, so you don't need to worry about that thing. And it is saying wrap any non-deterministic operation like a random number generation or operation with side effect, for example file writes, API calls, inside task, to ensure that when a workflow is resumed, these operations are not repeated for a particular run, and instead their results are retrieved from persistence layer. So whenever we have some function like API call or the function that will generate the random number, we'll create the tasks. We'll see in a while how to create the task. And after that it is saying when you resume a workflow run, the code does not resume from the same line of code where execution stopped. Instead, it will identify an appropriate starting point from which to pick up where it left off. And it is the same basically detail. It is saying that you must use task whenever you have to use logging file write or network call, and it is all the detail. You maybe read it out, it is the same detail. And after that it is saying LangGraph supports 3 durability mode that allow you to balance performance and data consistency based on your application requirement. One is a higher durability mode adds more overhead to the workflow execution. You can specify the durability mode when calling an graph execution method. The question is how we are able to specify the durability mode. Whenever we have to call the graph like graph.invoke or graph.stream, here we will specify durability is equal to sync. We have different options for durability. It is saying the durability modes from the least to the most durable are as follows. The first one is exit. LangGraph persists changes only when graph execution exits, either successfully, with an error, or due to human in the loop interrupt. Okay, perfect. After that it is saying this provides the best performance for long running graph, but means intermediate state is not saved, so you cannot recover from system failure. The thing here is exit is good, but whenever there will be system failures, for that purpose exit will fail. So durability mode, we need to change the durability mode. The second one is async. LangGraph persists changes asynchronously while the next step executes. This provides good performance and durability, but there is a small risk that LangGraph does not write checkpoints if the process crash during the execution. So with the asynchronous there is same issue. I mean, if there will be some crash or system failure, asynchronous will not work. The third and best option is synchronous. LangGraph persists changes synchronously. Before the next step starts, this ensures that LangGraph writes every checkpoint before continuing next execution, providing higher durability at the cost of some performance overhead. So synchronous is best option for us. And now let's see how to create the task. It is saying using task in node. If a node contains multiple operations, you may find it easier to convert each operation into a task rather than refactor the operation into individual nodes. Perfect. So how to do that? Let me just copy these lines of code, and I will paste here. Here we import the mandatory thing. Here we import request. Our state is URL and result. We'll pass some URL and we'll fetch the result from that URL. It is the node that is sending some request, and from that request we will get some data. Here we are saying request.get means we want to get something from this URL. We are passing the URL from the state, and we are saying .text means we want to get text from that request. We only want to get first 100 characters, that's it. And it will save the result in result this variable, this parameter basically. And here we are building our graph. Here we are saying thread id is equal to uid, and configuration is thread id is equal to thread id, and we are invoking the graph by typing https www.example.com. Before invoking the graph, let's store the final result or final state in a variable, and let's run it. Okay, it is giving some error. It is HTTP connection pool. I already run this and it was giving the same error. So what I did basically, instead of typing www.example.com, here we'll type www.chrome.com or google.com. And now let's print the result. The result is doc type is HTML item scope is equal to empty, and item type is this schema.org. Okay, it was the first method to call the API. The another best method is if we'll click here with task, and let me just copy this one and I will paste here. Here I will first of all type with task, and from this I will say choose markdown, and I will paste the whole code here. Here we import the mandatory libraries, and URLs will be the list of string, and in result we are saying it is not required, it will be list of string. Not required means it is optional. And here we are saying from langgraph.func import task. Here we create the decorator of task, and we create the function that is make request. Here it will say request.get url.text first 100 characters. It will return just 100 characters from that text. Okay, perfect. And it is the call API node. It is calling this make request, this function, and we are passing URL. For URL in state URLs, it will be basically a list, and we are fetching one URL at a time, and by fetching that URL we are calling this make request. And here we are saying for request in request, I just only want to get request.result. In this line we are updating our state. We are saying results will be equal to results, but here you maybe notice the parameter is result, so we need to change this also. It will be results. It is typo in documentation. Okay, now everything is perfect. The learning point from this class is whenever there will be an API call or the function that will generate the random number, we need to create the task for that, like this. We need to import from langgraph.func import task, and we need to wrap that function with the help of add task decorator, and we need to call that function here in our actual node. Here I will say final state is equal to graph.invoke. Similarly, I will change this also, www.google.com. Let's run it and let's print the final state. The URL are www.google.com, results is doctype HTML. You maybe want to specify another website like HTTPS, like maybe github.com. Let's run it. Now we have two URLs, one is www.google.com and another is github.com, and we have two results against each URL. And then it is saying resuming workflow. It is saying once you have enabled during execution in your workflow, you can resume execution for the following scenarios, like pausing and resuming workflow by using interrupt. We'll see in upcoming videos how to use interrupt and human in the loop. We'll actually build very real world projects and we'll use these concepts. So for now, that's it guys, and don't forget to like and subscribe. See you guys in next video.